Hello everyone. ScienceBoard is a podcast that shines a spotlight on the latest scientific technology from Japan. Your host is Ren from Science Talk. Today, let's talk about the incredible precision of our ears. If I snap my fingers on your right side, you know immediately it's coming from the right. How does your brain know? It measures the tiny time difference between the sound reaching your right ear versus your left ear. This is called the interaural time difference, ITD. Believe it or not, this difference is only a few tens of microseconds. To calculate this, the nerve signals from both ears must arrive at a specific spot in the brain at the exact same time. It requires incredible timing precision. Today, I will explain a new study from a Japanese research team that reveals how the brain builds these super precise cables. The research is focused on the auditory brain stem. Nerve fibers are coated with an insulation layer called the myelin. This myelin acts like the rubber coating on a wire, helping electrical signals travel fast. In the sound localization circuit, scientists knew that the shape of this myelin changes depending on the location. In the tract region, myelin is long and signals move fast. In the NL region, this is the processing center, myelin becomes short and dense to fine-tune the signal speed. But how does the brain know to change the myelin structure so perfectly? The research team made the surprising discovery using chicken brainstems. They found that the nerve fibers themselves release small chemical packages called vesicles along their length. Usually, nerves only release these at the end at the synapse. But here, they were releasing them along the cable. To test this, they used a toxin called the E10. This toxin blocks the release of these vesicles. When they blocked the vesicles, the results were clear. In the areas where myelin should be dense and precise, the myelin failed to form correctly. The microscopic images showed unmyelinated segments, gaps in the insulation where there shouldn't be any. This means that nerve fiber isn't just a passive cable. It actively communicates with the surrounding cells by releasing chemicals, telling them exactly how to wrap the myelin insulation. By doing this, the nerve fine-tunes its own transmission speed to achieve that microsecond precision needed to locate sound. This vesicle release mechanism is the secret engineer behind our hearing. That's all for today's ScienceBoard. This podcast is broadcast in both Japanese and English. I'd love for you to listen to the podcast and post your thoughts with the hashtag ScienceBoard. Thank you for listening and see you next time.